Prudent Scholars in association with Goa Headmasters Association.
Welcome students. Hope all of you are fine and safe at home. We are all aware that the present situation does not permit us to have our regular classes in the school. But that does not stop us from learning. Keeping this in our mind, here we start teaching science for standard 10th. Students, we will begin with a chapter 1, Chemical Reactions and Equations. You are familiar with the chemical change and physical change. You have learned this in the last year. I hope you remember that. If not, let's recall it. What is a physical change? A physical change is a temporary change. The change is reversible, and during that change there is no formation of a new substance. For example, melting of ice. When ice melts, it changes into water, but water, when it is frozen, it is back to ice again. Reversible. The same with the dissolving sodium chloride in water. You can get back the salt by the process of evaporation. Let's look in the chemical change. Chemical change is a permanent change. A new substance is formed in a chemical change. For example, burning of candle produces carbon dioxide. Here, carbon dioxide is a new substance. Next example, rusting of iron. You know, when iron is rusted, it combines with the oxygen in air and form iron oxide. It's something new. So, rusting of iron is also an example of chemical change. Now, let me tell you students, chemical change is nothing but a chemical reaction. In the language of science, chemical reaction is a process which transforms one or more substance into a new substance with a new properties. So, chemical reaction is a process which transforms one or more substance into a new substance with a new properties. And as I told you before, chemical reactions are associated with a chemical change. To understand more about a chemical reaction, we will do one activity. Let us burn magnesium ribbon. I have taken a piece of magnesium ribbon. Let me clean it with a sandpaper. I am doing this so that I am removing the layer of oxide from its surface, and I am exposing the pure metal. So, let us burn this magnesium ribbon now. You know students, while doing this experiment, be away from the burning of magnesium ribbon as far as possible, because it is not good to see this with the direct eyes. Here the magnesium ribbon is burnt, and you got, while it was burning, it burns with a bright white flame, and you got a white powder in the watch glass. This white powder is nothing but magnesium oxide. Now, can you get back the magnesium ribbon now? No. you got a new substance, that is magnesium oxide. So, from this activity you have understood that chemical reaction is a permanent change, and in every chemical reaction a new substance is formed. So, from this activity we have learned that magnesium reacts with oxygen present in air to form magnesium oxide, and a chemical reaction has occurred. So, let us sum up. What is a chemical reaction? Chemical reactions are the processes in which new substances with the new properties are formed. See students, this is the first concept you are learning in this lesson. What is a chemical reaction? Chemical reactions are the processes in which new substances with the new properties are formed. Let us go further. Now we know what is a chemical reaction. But how are we to know that whether the chemical reactions has taken place? Of course, there are some observations which will help us to know whether the chemical reactions has taken place. Now, these observations are: during the chemical reaction there may be a change of state from solid to liquid, liquid to gas. Again, there can be a change of color. In a chemical reaction, there may be a change of color. Next, during the chemical reaction, there may be evolution of gas. For example, when zinc reacts with sulfuric acid, hydrogen gas is evolved. And also the next observation is chemical reactions takes place with a change in temperature. There are chemical equations which involves absorption and release of energy. So, these are the observations which will help you to know whether the chemical reaction has taken place. So, this is the second thing you have to remember. First thing, you learn what is a chemical reaction. Second thing, what are the observations that will help us to know whether the chemical reactions has taken place? One, change of state, change in color, evolution of gas, and change in temperature. Hope it is clear to you students. We will move on to the further. So, we have learned what is a chemical reaction. Also, we learned what are the characteristics of a chemical reaction. Next, moving on, we will learn now how to represent a chemical reaction. There are different ways of representing a chemical reaction. There are three ways mainly. One, in the form of sentence. Second, you can represent a chemical reaction with the help of word equations. Third, with the chemical equations. So, there are three ways of representing a chemical reaction. One, the form of sentence. Two, word equations. Three, chemical equations. Let's see this one by one. First, how to represent a chemical reaction in the sentence form? Let me tell you, it is a very long process and it is not convenient. It is time consuming because we have seen just now one activity of burning of magnesium ribbon. Let's write that reaction in the form of sentence. When magnesium ribbon is burned in air, it gets converted into magnesium oxide. You have to write the entire sentence. It takes time. That is a disadvantage of that. So, what is the next way of expressing it? Word equations. Here, we use the names of the reactants. Now, you got a new term, reactants. What do you mean by reactants? Look at the equation. Magnesium plus oxygen gives magnesium oxide. Here, what are the substances which are taking part in the reaction? Of course, that is magnesium and oxygen. So, students, the substances which are taking part in the reaction are called reactants. So, I hope you understood what are reactants. Reactants are nothing but the substances which are taking part in a reaction. Now, reactants are always written in the left hand side. As you can see here, the left hand side the reactants are written, whereas the products. Now, what are products? The products are the substances which are formed after the chemical reaction. That means the new substance which are produced after the chemical reaction are called products. Here there is only one product, that is magnesium oxide, and the products are written in the right hand side. So, I hope you understood the difference between reactants and products. Reactants are the substances which are taking part in the chemical reaction. Products are the new substances which are formed after the reaction. Reactants are written in the left hand side, products are written in the right hand side. Now, if there are more than one reactant, we can separate it by using the plus sign. Here magnesium plus oxygen it is written. The same with the product. If there are more than one product, you can use a plus sign. Here only one product is there. And between the reactants and a product, there is an arrow which points towards the product and which indicates the direction of the reaction. I hope you have understood about the word equations. Here we use the name of the reactants. We don't write in the sentence, we only write the name of the reactants. Next way of representing a chemical reaction is by writing chemical equation. This is the most convenient form because it is the shortest form. Here we don't write the names, we write the symbols and the formulae. I hope you remember in 9th standard you have learned the symbols of the elements. Oxygen, the symbol of oxygen is O, symbol of hydrogen is H. I hope you can recollect it. The same we have learned the formulas also, how to write the formula by knowing the valencies of the element. Okay, let's come back here, the chemical equation. Chemical equation, as I said, we use symbols. We can say it is a symbolic representation of a chemical reaction. Symbolic representation of a chemical reaction is known as a chemical equation. Here I have given examples of two equations. One, we have already seen this. 2 Mg plus O2 gives 2 MgO. You must be wondering from where the 2 came. The 2 is after balancing, which I will be dealing later on. Next, the symbol of magnesium is Mg. The symbol of oxygen is O. Molecular formula is O2. The formula of magnesium oxide is MgO. Let's see another example. Zinc reacts with sulfuric acid, that is Zn plus H2SO4 gives ZnSO4 plus H2. Here, what are the reactants here? Zinc and sulfuric acid. Whereas, what are the products? Zinc sulfate and hydrogen. So, here instead of words in this type of expression, we use symbols and formulae. So, I hope it is clear to you the three different ways of expressing a chemical reaction. Let me tell once again, in the form of sentence, in the form of word equations, last in the form of chemical equations. And among these three, the most convenient and the best method is chemical equation. Let's learn further. So far you have learnt what is a chemical reaction, what are the characteristics of a chemical reaction. Then we also learned about how to express a chemical reaction. 3 concepts we learned. Next, what do you mean by a balanced and unbalanced chemical equation? Okay. What is a balanced chemical equation and unbalanced chemical equation? Let us see, I have given an example here. Zn plus H2SO4 gives ZnSO4 and H2. Now, I say that it is a balanced chemical equation. How do we know it is a balanced chemical equation? What do you mean by the word balanced? Balanced chemical equation will have equal number of atoms of the element in the reactant and equal number of atoms of the element in the product. That means number of atoms in the reactant will be equal, will be same to the number of atoms of the element in the product. Let us see it more clearly. Let us write the name of the elements in this equation. The first element is zinc. The next one is hydrogen, symbol of hydrogen H. And the third is sulfur. And the fourth is oxygen. In the reactant side. Okay. Now let us count the number of atoms of these elements in the left hand side. So zinc, there is only one atom. Hydrogen, as you can see, there are 2 atoms of hydrogen. Sulfur, there is only one atom. As you can see, oxygen, there are 4 atoms of oxygen in the left hand side. Let us see whether it is same in the right hand side. That is the products. Zinc, only one. Sulfur, hydrogen, there are 2 hydrogen. The left hand side also 2. Sulfur, 1 sulfur in the right hand side. The left hand side also 1. Oxygen, 4, both in left hand side and right hand side. So here you can see every atom of the element is balanced. It is same both in the case of reactant and in the case of product. So that is the reason we say this equation is a balanced chemical equation. At the same time, let us look at the next equation. This chemical equation, Mg plus O2 gives MgO. Let us see the elements in this second equation. Magnesium Mg and oxygen O. Number of atoms of magnesium in the left hand side is 1, right hand side is 1. Correct. What about oxygen? There are 2 atoms of oxygen in the left hand side, but here it is only 1. This particular equation is unbalanced. The unbalanced equation is also known as skeletal equation. So, what do you mean by a skeletal equation? Skeletal equation is nothing but an unbalanced equation. So, the equations can be balanced and unbalanced. Unbalanced equation is also known as skeletal equation. Students, it is a must that we must balance chemical equation. It is a must. Why? Why should we balance a chemical equation? Again, last year you have learned law of conservation of mass. The total mass of the reactants before the chemical reaction is equal to the total mass of products after the chemical reaction. It is called the law of conservation of mass. Mass is neither created nor destroyed, it is conserved. So, therefore, the atoms of the reactants must be equal to the atoms of the product. Hence, we need to balance the chemical equation. So, skeletal equation is an unbalanced chemical equation. So, skeletal equation is against the law of conservation of mass. So, we cannot violate the law of conservation of mass. This is the reason we must balance the equation. There is a need to balance the equation. I hope you have understood. We are going next, balancing a chemical equation. You know students, it is a very important concept in chemistry. And often many students get confused with this. But if you know the correct method of doing, then you will enjoy doing it. So let us learn how to balance a chemical equation. Here we start now. I have written a chemical equation. You can see Fe plus H2O gives Fe3O4 plus H2. We need to balance this chemical equation. Students, we have 5 important steps to follow this. I hope you can understand. We have to go balancing equation step by step. So, in the step 1, what we have to do first? You have to count the number of atoms of elements on both the sides. How many number of atoms of each element? Here, Fe is one element, next is hydrogen, next is oxygen. So, we got 3 elements here in this equation. So, what is the first step to do? Count the number of atoms of elements on both the sides. So, let us start. Element, number of atoms, the left hand side, that is a reactant, and number of atoms in the right hand side, that is product. Let us count now. First element, iron. How many atoms are there here? Only one, correct. And in the product, 3 atoms of iron. So, in the left hand side is 1, the right hand side is 3. Write as it is. Next element is hydrogen. How many hydrogen atoms in the left hand side? 2. And in the right hand side also 2. The next element is oxygen. How many atoms of oxygen in the reactant side? 1. And here in the product there are 4 atoms of oxygen. This is the first thing you have to do before starting balancing a chemical equation. What you have to do? Count, just count the number of atoms of the elements in both the sides, on both the side, reactant side and the product side, and write this way. Is it clear? Shall we go to the next step? Step 2. So, what have you done in the step 1? You have just counted the number of atoms of the elements on both the sides. In step 2, we have to really start balancing it. For that, you have to select, in the chemical equation, you have to select a compound which contain maximum number of atoms. Select. Okay, this is an element, this is a compound, this is another compound, this is an element. So, select the compound which contain maximum number of atoms. Can you tell me which compound here? Yes, it is Fe3O4, iron oxide. In that compound, look at that compound again. In that compound, select an element which has got more atoms. So, iron has got 3, oxygen has got 4. So, here which element has got maximum number of atoms? That is oxygen. I hope you can understand. In this equation, first you have to look for the compound with the maximum number of atoms. In that compound, look for the element with the maximum number of atoms and we have selected oxygen here. And now atoms of oxygen. In the initial stage, okay, there was only one oxygen, the reactant side. But in the product side, there is 4 atoms of oxygen. Now, we need to balance oxygen. So, how to do this balancing? To balance, remember, you cannot make any changes in the subscript. These are the subscript. You cannot make any changes here. You can make changes in the coefficient. So, to balance oxygen, the reactant side, let us multiply this with 4. So, when you write 4 here, you get 4 oxygen in the left hand side, 4 oxygen. This 4 is applicable for oxygen as well as hydrogen. Now, hydrogen, number of atoms of hydrogen now becomes 4 2s are 8. Let us go to hydrogen later, we will come back here oxygen. Now, we have balanced oxygen, 4 1s are 4, here also 4. So, oxygen is balanced here. Now, it is a partially balanced equation, not fully. We have balanced only oxygen. So, the equations looks like this. Fe plus 4H2O gives Fe3O4 plus H2. There are 4 oxygen in the reactant side and there are 4 oxygen in the product side. I hope it is clear, students. In the step 2, what you have to do. Now, we will go to the step 3. We have a partially balanced equation with us, that is Fe plus 4H2O gives Fe3O4 plus H2. Balancing is not completed, still we need to balance 2 more elements. So, let us do that in the step 3. Now, we have got 2 more elements, one is iron, other one is hydrogen. You can select whichever you want. So, let us now balance hydrogen atom in the partially balanced equation. So, here let us see the atoms of hydrogen now. We have seen the atoms of oxygen. We have done with that. Now, atoms of hydrogen. In the initial stage, in the reactants, now how many number of atoms of hydrogen? You have to multiply this, 4 2s are 8. 4 molecules of hydrogen, that means 8 atoms of hydrogen. But in the product, there is only 2 atoms of hydrogen. So, how to balance this hydrogen? I had told you before, you cannot make any changes in the subscript. 3, 4, 2 are the subscript. We cannot make changes. If we make changes there, then we are changing the entire formula of that. We can only write the number here. We can write the coefficient here in front of hydrogen. So, to make it 8, you have to multiply this with 4. So, when you write 4 here, 4 2s are 8. So, the hydrogen becomes balanced. Let us see the equation how it looks like now. Fe plus 4H2O gives Fe3O4 plus 4H2. Here this is the equation with the 2 elements already balanced. Which are those? One is oxygen, other one is hydrogen. Hydrogen is 4 2s are 8 in the reactant and 4 2s are 8 in the product. Oxygen once again, 4 oxygen in the product and this 4 is applicable for hydrogen as well as oxygen. So, there are 4 oxygen in the reactant also. So, I hope it is clear so far. We have got only one element is remaining to balance. We will see that how to do that. This is the step 4. We have the equation like this with us. Now, examine the equation and pick up what is left now. What is left is iron. Now, to equalize iron atom, here 3 atoms of iron is there. You just put coefficient 3 before iron. So, 3 atoms of iron. The beginning initially only 1, the product 3. When you put coefficient 3, it becomes 3 Fe and the product also 3 atoms of iron. Now, we have an equation this way. Step 4 is over, we have done with the balancing. Now, the step 5, we are only checking whether it is balanced or not. Now, we have the equation this way. Let us see the next step. Finally, step 5. As I told you at the beginning, balancing equation consists of 5 steps. Fifth step is only to check and make sure that every atoms of the element in the reactant and the product are balanced. Finally, let us check the equation by counting the number of atoms on both the sides. Element, number of atoms in the left hand side, number of atoms in the right hand side. What is written on the left hand side? Reactants, and the right hand side products. Let us start from iron. Iron, there are 3 iron atoms here and 3 iron atoms in the product. It is balanced. Next, hydrogen. How to count hydrogen atom? 4 2s are 8. 8 hydrogen atoms. 8 hydrogen atom in the reactant, and here in the same way 8 hydrogen atom in the product. Next, what is left now is oxygen. 4 oxygen, this 2 is only for hydrogen, okay students, it is not for oxygen. This 4 is for hydrogen as well as oxygen. So, here 4 oxygen in the reactant, and here of course 4 atom of oxygen in the product side. So, all 3 elements iron, hydrogen, oxygen are balanced before the reaction and after the reaction. Thus, we can say the equation is balanced. I hope you have understood step by step. I will be giving you more examples at the end of the lesson. Now, the above equation is fully balanced. Now, we call it as hit and trial method. For this kind of balancing, we call it as hit and trial method. Why? Because we make trials by using the smallest whole number coefficient. That is why we call it as hit and trial method of balancing a chemical equation. Next, we have balanced a chemical equation. Still, if we want to give more information about the chemical equation, we can still give more information by writing the states of matter. For example, the physical state of a reactant and a product also can be written. So, to make the chemical equation more informative, the physical state of reactant and product can be written along with the formula and symbols. For example, if you want to write solid, solids can be just denoted by S. Liquids can be denoted by writing small letter L, and gases can be denoted by G. Solutions in water is expressed by writing AQ. What is AQ? Aqueous solution. Solution made with the help of water, where water is a solvent. Now, if in a chemical reaction, if there is an evolution of gas, you can put the arrow mark pointing upward. That means a gas is evolved. Suppose in a chemical reaction where if a precipitate is formed, that also you can show by putting an arrow mark which points downward. So, upward arrow mark shows the evolution of gas and downward the formation of precipitate. Example, calcium hydroxide, CaOH2, aqueous, because it is lime water. Solution is made in water, plus CO2 is a gas, gives calcium carbonate, again it is a solid, and water liquid. Students, however, writing the physical state of reactants and product in a chemical reaction, in a chemical equation, it is not compulsory. So, let us move on to the next one. Let's recall what all we have learned so far. We have started with a chemical reaction. We have seen a chemical reaction. We learned the characteristic of a chemical reaction. I hope you remember: change of state, change of color, evolution of gas, change of temperature. Next, we learned what we mean by reactants and product. Then we learned also about how to write a chemical reaction in 3 forms: in the sentence form, in the form of word equation, and chemical equations. We also learned what do we mean by skeletal equation and what is a balanced equation. The next, we learned how to balance a chemical equation. And the last, we learned what are the common representation in an equation, whether the physical state of a reactant also can be mentioned. For example, solids can be denoted by S, liquids L, gas with a G. All these are the different common representation in an equation. I hope you have understood this session. Thank you, students.